Many times when dealing with machinery in manufacturing situations, you have to count items. Whether you're putting products in a box or 2 dozens of bottles into a container, you need to count the items coming off the machine. Every PLC has counter instructions. Although they may be programmed differently, they operate the same way. So once you become familiar with one, the rest are easy to learn. The two main types of counters in PLC is counter up and counter down. The choice of which to use depends on the tasks to be done. For example, if we're counting the finished products leaving a machine, we might use a counter up. If we're tracking how many parts are left, we might use counter down. Most PLC contain both up and down, and here are some of the other examples of the counters used. This is the configuration of a typical PLC counter function. A counter instruction is an output instruction. Most PLC counter counts the false to true transition of the rung input logic. The counter instruction counts each time the input logic changes the rung from false to true. Counters normally use the low to high transition from an input to trigger the counting action. Simply, when the rung is activated, the counter counts 1. And we need the rung to have the false to true transition for the counter to continue counting. Input logic can be a signal coming from an external device like a sensor or an internal logic as we learned before. Each time the counter instruction sees false to true rung transition, now depending on the counter type, a counter up counter, accumulated value, is incremented by 1. A counter down counter accumulated value is decremented by 1. The type of the counter is usually written on the top of the instruction. The counter instruction has generally 3 values associated with it: counter name, counter preset, and accumulated value. A typical counter counts from a 0 to a predetermined value that's called the preset. The preset value specifies the target number of counting, while the accumulated value indicates the actual number of counts that have already occurred. So here's an example. If you want to count from 0 to 100, you would count up and use a counter up counter. The predetermined value of 100 would be the preset value, and the accumulated value is the current or accumulated count. So if our counter had counted 45 pieces that had passed on the conveyor, the accumulated count or the value would be 45. And when all 100 pieces had passed on the conveyor, the counter accumulated value and the preset would be equal. At this point, the counter would signal that the counter is done counting and it's complete. Counters need a reset instruction for it to reset back to 0. The reset instruction name should match the counter name. Now, a counter down works a little bit different. Each time a count down counter sees a false to true transition, its accumulated value is decremented by 1. Since the accumulated value is decremented each time the input logic changes the rung from false to true, the accumulated value must be starting point of the count. Counters in PLC come with bits that are associated with them. Each bit is activated at a certain task. CU when the counter is counting up, CD when the counter is counting down, and then the done bits counter is when the counter is done counting. The accumulated is equal or greater than the preset value. The way to use the bits is by using the name of the counter and then select the specific bit attached to it.